First thing, let's go through it this way. I'll try it this way this time and see if I can make it make more sense. I always hate teaching this lecture because people just like get, it's one of those lectures where people are just like kind of done by the time and you're not even finished talking. Whatever, it happens. So the major nerve plexuses. So they're named for regions or locations. And of course you can tell all of them when you look at this whole picture. But what I want to do is make sure that you can tell them when they're sort of isolated, and it's really not that hard. Okay, so the cervical plexus is coming out from C1 through C4 or C5. You with me so far? The brachial plexus is about C5 through T1. There's just some fibers from T1 in there. This one doesn't form a plexus. The lumbar plexus is about L1 through L4 or L5. And then the sacral plexus is L5 through usually S4. So how do you tell them in isolation? Just let's make sure that you can do this, okay? So can you tell that this is the cervical plexus even if it wasn't labeled? How? Yeah, atlas and axis. Use things that you know to make sure that you can tell. Okay, how about this one? How would you tell that this one was the brachial plexus? Yeah, because the brachial plexus goes through T1. And T1 has the first rib attached to it. So you can use that as orientation. Does that make sense to you? Okay. And then this one, we'll skip and we'll go back to that one in just a second. Can you tell that which plexus this one is? The sacral plexus. Okay. Now there's only one left. And by process of elimination, can you tell that that one is the lumbar plexus because it doesn't have any of the other landmarks? Yes? Okay. So I don't usually ask you to identify individual nerves out of a plexus on a picture. You have to know that they're part of a plexus, and you have to be able to recognize the plexus on a picture. But wouldn't it be kind of stupid for me to make you identify the femoral nerve like that? Because it doesn't look a damn thing like that in an actual person. No, it does not, okay? But do you have to know that the femoral nerve is part of this plexus and what this plexus is? Yes. Okay, that makes sense? Okay, so it's a much better place to ask those things when you're identifying the individual nerves on a cadaver because you can see where they actually run. But I will try to put it together with lecture and lab. Okay, so what we are going to do is we're going to start with the major nerve plexuses and we're going to go from the top down. So we're going to start with the cervical plexus. Now the cervical plexus does a lot more than you memorized in lab, and most of it is logical, but you didn't learn a whole bunch of the muscles that it innervates. So what the cervical plexus primarily does, guys, is innervates anterior neck muscles. There's a whole bunch of little bitty muscles in here that you didn't learn because they're really hard, okay? It innervates all of these anterior neck muscles, not the platysma, but a bunch of anterior neck muscles, and it innervates the sensory function of the neck and the bottom part of the head. So you feel this and you do this, yes, with the cervical plexus. But then one other really important thing, right? The other really important thing that it does is this nerve right here, the phrenic nerve, wanders down and innervates what? It innervates the diaphragm, right? And that's pretty damn important. Can we all agree? Okay, it innervates just motor function of the diaphragm. That's all it does is motor function of the diaphragm. It's in your notes. So the phrenic nerve only innervates one muscle. It has no sensory function. The muscle is the diaphragm right there. No, yours doesn't have that in it. So it innervates the diaphragm. So let's look at sort of the path of the phrenic nerve to figure out, as far as spinal cord injuries, how high do you damage a spinal cord and still maintain some diaphragm function? So the question I asked you is, where would one have to injure the spinal cord to lose innervation to the diaphragm? So look at this picture with me for a second. Do you see C5 right here has some processes that go to the phrenic nerve? Do you see that? Do you see that C4 has some that go to the phrenic nerve? And how about C3? It has some that go to the phrenic nerve as well. So C3, 4, 5 keeps you alive. Okay, so if you innervate between C4 and C5, you'll probably lose some of the function of the diaphragm, but not complete, yes? Damage above C4, probably lose most function of the diaphragm. Damage above C3, you're probably dead. Does that make sense? Okay, and a lot of times people who have damage this high are on a ventilator, like Christopher Reeve before he died. I think his damage was between C3 and C4, I can't quite remember, and he could be off his ventilator for a little while and then had to go back on it. It was really exhausting for him to generate those diaphragm contractions. Okay, everybody okay with the phrenic nerve? Okay, and the phrenic nerve, by the way, when you identify it in a cadaver, you don't usually identify it coming off of here. You could if the dissection was done, but there's a pair of phrenic nerves that go down to the diaphragm, and so you identify them in the thoracic cavity. Everybody okay? So that's where you would look for that one. Okay, so there's a whole bunch of other nerves here, and it innervates all of this muscularity and all of this sensory function, right? So that, not the phrenic nerve, but the cervical plexus does that, okay? All right. So, and now to the brachial plexus, and the brachial plexus is the next one down, and the brachial plexus comes from some cervical spinal nerves, and then the first, usually only T1, sometimes T2 will get involved too. So let's look at that one, okay? So see all the roots, C5 through usually T1, okay, going out, and the brachial plexus is going to go and primarily innervate the arm and the forearm, but also a little bit of the shoulder and a little bit of the chest. Okay, so this whole region right here is what it's going to do. And you have to know a hell of a lot of nerves and a hell of a lot of functionality out of that one. It looks really hard initially, but it's not that bad. Okay, there is a pattern to it. So let's go ahead and I'm going to erase this and I'm going to teach you guys how I do it when I look at any new cadaver. The brachial plexus is the hardest one for me, but there's a pattern that actually makes it clarify pretty quickly. So the first thing you have to do is, of course, know where to look for it. And the way that we do the dissections, you're going to primarily be looking in the armpit, right? Okay. But the next thing you need to be able to do is to be able to look at that bowl of spaghetti and figure out what is a nerve. Okay. So hopefully you figured out how to tell arteries and veins from nerves, yes? Put some gloves on and roll them in your fingers. Right? If they're hollow, they're a vessel. Very quickly, you'll figure out how to tell an artery from a vein. Arteries just stand up and veins collapse, pretty much. So if they're hollow, they're a vessel. If they're solid and they roll between your fingers and you can kind of feel fibers in there because that's what a nerve is, a bundle of myelinated axons, then it's a nerve. Does that make sense? Okay. Nerves are pretty solid, except for the tiniest ones. They're not really super easy to break. The tiniest ones are, but the other ones aren't. So you have to tell arteries, veins from nerves. And after you're just looking at nerves, because the arteries and veins are not going to get out of the way. You just have to know what to ignore when you're actually looking at it. Then what you need to be able to do with the brachial plexus is to find the pattern in the brachial plexus. And to find the pattern in the brachial plexus, this is the one that I use. There's probably 10 right ways to do it. But do you see, follow me, do you see this M? Goes up, goes down, goes back up, back down. Do you see that? Okay. Now, you have to make sure that you connect to the right part that actually goes to the middle of the M. So this is not part of it. Does that make sense? So all the way up, all the way back down, all the way back up, all the way back down. Everybody see it? That's the M. So I'm going to draw it here. And I'm going to tell you how I use that M to do process of elimination and find all of the nerves of the brachial plexus. Everybody good? Okay, so I'm looking at the right arm and the right armpit, okay? And everybody can find the M, right? Okay, how many of you guys were able to find it in cadavers? Good, awesome. So once you find the M, the long lateral portion of the M is what nerve? Who remembers? It's the musculocutaneous. Good. The middle of the M is named exactly what you would want it to be. What is it? That's the median nerve. Okay? And the medial nerve, not median, but the one that is most medial, is the what nerve? Yeah, that's the ulnar nerve. Okay? Everybody good with that? Okay. So that's 3 of them. There are a few more before we actually get into the last one. So we've got these 3 in its process of elimination. We have 3 more that actually don't go into the arm, but stay with the torso. Yeah? But those are pretty easy as long as you know what you're looking for. There is one that goes down and runs lateral, and actually synapse is right here on the side, Anybody know what that one is? That is the long thoracic. Don't be at all surprised if it innervates a muscle that is right here. Cool? And then I've got two more. These two are these guys right here. The medial pectoral nerve and is the lateral one on here? I think the lateral one's on here. Okay, lateral pectoral nerve. So these two, you could identify them out there, but that's the hard place to do it. So follow them to where they go. And where they go is the lateral and medial pectoral nerve. Those go, how would I find them on a cadaver? I would separate the pectoralis major and the minor, and I would find them between there. And we'll talk about which one does what in a minute, okay? So I've got 3 nerves going down here. I've got 3 here. I've got 2 left. But the 2 left are actually really easy after we've already done all of these 6. Because the 2 left are, one, that immediately, where is it in this picture? I'll show you in this picture. One, oh yeah, axillary. One that dives right into the armpit, and it's really tight. So it doesn't run long with the other ones. It dives right into the armpit, and it's really tight. It doesn't have much wiggle to it. What's that one called? Yeah, that one's called the axillary nerve. Okay, and there's only one left. And the radial. How do you find the radial? And this is important because when we start talking about what the radial is, knowing how it courses is going to be really important. So what the radial is going to do is, let me show you this picture. Okay, so the radial is going to start out up here in the armpit, and then it's going to dive behind the humerus. Do you see that? And then it's going to run lateral all the way down to the hand. So if I drew it right here, it would go behind and out. And this is the radial. Okay? So do you see that if you're looking for it running with the M, you're looking for it in the wrong place? Because it actually starts out and then it dives behind. Good? Okay. The directions that these go are actually really important for trying to figure out which muscles they innervate. So knowing where to look for them, knowing whether it's anterior, posterior, lateral, or medial, ends up making sense of the muscles that it innervates. Okay? So now that's what we're going to do with this one, is look at what muscles each of these innervate. Everybody good? Okay. So let's find the M here too. Stick with me for just a second. Do you see the M? Musculocutaneous up, median down, yes. Go back up, ulnar, cool, okay. And the axillary, do you see it diving into the armpit and not being very long? This one doesn't have the 3 that goes to the chest, but don't worry about it. The only other one you have to find is the one that dives behind the humerus and then goes lateral all the way down. Does that make sense? Okay, so now with that in mind, let's look at what they do, okay? All right, so what they actually do, okay, the brachial plexus, big picture, is really innervating the muscles and the skin, both sensory and motor. So the M stands for motor, the S stands for sensory. This is all somatic, by the way, of the chest, the shoulder, and the arm. Okay, so the long thoracic nerve. The long thoracic nerve goes right here. Anybody know what muscle it innervates? Yeah, it innervates the serratus anterior. Does that make sense to you? Okay, so the long thoracic nerve innervates the serratus anterior, and I think you can see it right here. Do you see it right here? The long thoracic nerve going right here, okay? So it's lateral, it comes right out of the armpit and then runs right along the side of the chest. It should be pretty easy to find, okay? In this picture, they don't actually show the medial and lateral pectoral nerves because, again, you have to lift up the pec major and pec minor in order to find them. I mean, you can see them from here, but you can't really see what they're doing. So that's not where I would find them in a cadaver. So the medial pectoral nerve innervates 2 muscles and has no sensory function, okay? And those 2 muscles are both pec muscles. So the medial pectoral nerve innervates both pec muscles. And then here's your logic question for you. Which one of those muscles is big enough that it might need innervation from two nerves? Yeah, the pectoralis major. Good? So the major gets both, the minor just gets medial. And I always remember what innervates the minor by thinking about which of those two muscles is more medial. Does that make sense? The medial pectoral nerve innervates the minor. The minor is slightly more medial than the major because the major goes all the way out to the arm, right? Okay, so regardless, the medial does both, the lateral does one. Yeah? Everybody okay with that? And neither one of them have any sensory function. Cool? Okay, so axillary nerve. Axillary nerve does armpit stuff and shoulder stuff. So what is it actually going to innervate? Well, you can kind of sort of figure it out by where it's going. Do you see where it's going? Is it going to surprise you if it innervates the deltoid muscle? No, it shouldn't surprise you. So what is that actually going to do? So let's look. The axillary nerve is going to innervate the deltoid and the teres minor. Okay? And then as far as its sensory function, what's it going to do? Its sensory function is here, really the outer portion of the shoulder. And then its motor function is really the outer portion of the shoulder as well. Okay? The minor does a little bit other stuff, but outer portion of the shoulder. Does that make sense? Okay? So axillary muscle. So you feel here and you kind of do this with the axillary muscle. Is that okay? Okay. Sorry, axillary nerve. So that's the axillary nerve, deltoid and teres minor. Okay, and now we get into the ones that are confusing, in which it's really, really helpful if you can start to see a pattern. But the pattern takes a minute to clarify, so we'll try to get it together. Okay, so the median nerve, watch where it runs. Okay, so let's find the median nerve right here. It's the middle of the M, and watch that it runs down the anterior surface of the elbow, all the way down the middle to kind of the lateral portion of the hand. Do you see that? Lateral portion of the hand, lateral fingers. So let's look at what it does. And it should make sense to you. First off, its sensory function is that it actually innervates the lateral digits of the hand. So it feels here. Yes? These lateral digits of the hand. Good? Because that's where it went. Does that make sense? So its sensory function is primarily the lateral digits, also these two fingertips. So, and what about its motor function? Its motor function is primarily to innervate 6 of the anterior forearm muscles, mostly on that side, middle to that side, because that's where it ran, right? Okay, so let's see which ones. So 6 anterior forearm muscles. Not surprisingly, you got a lot of flexors in there. You don't have to write this down. Remember, it's going to be on the video. You'll be all right. Okay, let's try to make it make sense. What's the FCR? Flexor carpi radialis. That's on the lateral side. What's the FDS? Flexor digitorum superficialis, which is quite right down the middle. Okay. Pronator teres, which was up here. Okay. FDP. Flexor digitorum profundus, but only the lateral part, which should make sense because it's running more lateral than medial. Everybody with me? Okay. FPL. Flexor pollicis longus. Pollicis is on the lateral side too. You with me? Okay. And then the palmaris longus, which is right down the middle. Okay. So if we try to simplify a pattern for what the median nerve does, here's what I would tell you. The median nerve feels this, yes, and primarily does that. Does that make sense to you? Yes? Feels this, does this. You got a little pollicis action too, but that's okay because it's on the right side to be doing the pollicis. But is it flexing or extending anything? It's flexing, right? Okay, so it feels this and it does that. Okay, everybody good? Okay, so that's how I remember when I get stuck. Because you're taking a lab practical and you can't exactly remember which muscle this innervates, but then you have a pattern to help you make an educated guess for when you can't remember. Does that make sense? Okay, because sometimes memorization leaves you. We all know that. Okay, all right, so let's go to the next one, the musculocutaneous nerve, but let's look at where it courses first. You ready? Okay, so the musculocutaneous nerve is this one right here that runs along the anterior portion of the arm, right? And then it's going to go past the elbow, and then it's going to go more lateral, right? Musculocutaneous that you've got right there. So let's see what that one actually does. The musculocutaneous nerve is going to do the anterior arm muscles here. It's running right over them. It's going to be really easy to innervate them. And then its sensory function is going to primarily be the lateral portion of the forearm. So let's look at it. What is this one going to do? Well, it's going to innervate everything with the brachii in it. The brachialis, part of the biceps brachii, and the coracobrachialis, because it's running along the anterior surface of the arm. Everybody okay with that? Okay. And then, so here we go, 3 anterior arm muscles. Biceps brachii, brachialis, and coracobrachialis. Everybody okay with that? And its sensory function has to do with where the nerve goes after that. So where the nerve goes after that, that's not the one I want. Where the nerve goes after that is down here. So although it's weird, what does this musculocutaneous nerve do? And the name kind of tells you because it's musculo first and then cutaneous. Does that make sense? So it innervates this muscle and it innervates this portion sensory. So what does the musculocutaneous nerve do? It feels this and does this. You with me? Feels this, does this. What does the median nerve do? Feels this, does this. What did the musculocutaneous nerve do? Feels this, does this. Does that make sense to you? Okay. Musculocutaneous nerve. Everybody okay with that? Okay. All right. So now the ulnar nerve. Let's look at where it runs. Okay. So the ulnar nerve is down here. Notice that it runs all along the medial surface of the arm, and then which fingers does it end up in? These two, right here. Okay. Don't be at all surprised that it actually is going to help with this and then feel this. So let's look at what the ulnar nerve does and pick up the last little part of it. So the ulnar nerve is going to pick up those last 2 anterior forearm muscles that we hadn't innervated yet. Probably some flexors, probably with an ulnar in it somewhere, okay? And then it's going to innervate sensory function of just the ring and the pinky finger, because we already did these with what nerve? Median. And what's this one? Ulnar. Yes? Okay, so let's look at what it does. So the ulnar does the flexor carpi ulnaris. That should make sense to you. And then the only other one that I had left was the flexor digitorum profundus, the medial portion, because we already did the lateral portion. Does that make sense? Okay, so you guys tell me, what does the ulnar nerve do? It feels where? Here. Feels here and does this. Yes? What's its friend that does the other thing? Median nerve feels here, does this. Yes? That makes sense? So that's the pattern that you have with those damn forearm muscles that we all, well, some of you guys love. I hate them. Everybody okay? Okay. All right. You guys are not asking very many questions at all. Okay. The radial nerve is a freaking workhorse. But I want you to look at what it does so that you can understand the workhorse work that it does. Okay. So can we all agree that we haven't innervated a damn thing on the backside of the arm? Well, guess where the radial nerve runs? All along the backside of the arm and all along the backside of the forearm. A little bit lateral, but still all along the backside. So don't be at all surprised that everything that was left, the radial nerve is going to do. Cool? And so let's look at the pattern of what the radial nerve actually accomplishes. So the radial nerve is going to do sensation almost all the way down to the dorsal surface of the hand. So the entire back of the arm almost to the dorsal surface of the hand. Now, remember the deltoid took care of some of this sensation up here. The rest of it that's left is all going to be radial. Good? Okay, fingers we don't have to worry about yet. All right, so what muscles is it going to do? Well, pretty much everything that was left it's going to do, so let's look. So what it's actually going to do is 3 posterior arm muscles. What's back there? Triceps, the anconeus, the brachioradialis, supinator, and then all of those extensors. Yeah? Okay, so the extensors are all going to be the ECRL. What's that? Extensor carpi radialis longus. ECRB. Extensor carpi radialis brevis. ED. Extensor digitorum. ECU. Extensor carpi ulnaris. EPL. Extensor pollicis longus. EPB. Extensor pollicis brevis. APL. Abductor pollicis longus. Okay? All right. So let's get the pattern. So the radial nerve, the workhorse of the arm and the forearm, feels where? All the way down, and does what? This and this. Extension at the elbow and extension at the wrist. Yes? Isn't it doing both of those? Together with a little bit of abduction, right? Because that was right next to an extensor, right? Does that make sense? So the flexor was what muscle? The flexor pollicis? What was that? I mean, what, a nerve? Yeah, the median, right? Okay. And then the extensor and the abductor are what? The radial. Does that make sense? Okay. So, everybody okay? Not do you love it, but can you do it? Okay. So, let's go through it one more time. You ready? Okay. See if you can tell me if I just throw a nerve out there. Who remembers what the musculocutaneous nerve does?
Feels here.
Feels here, does this. Does that make sense? That means it innervates these muscles, all three with the word brachii in them. Okay. Musculo, then cutaneous. Okay. How about median? What does the median do? Feels here, does what? Does this. Good? Okay. What does the radial nerve do? Feels here, does what? This and this. Yes? All of the extension that's going on past the shoulder. It doesn't cross the shoulder. It doesn't actually innervate the shoulder. Does that make sense? Okay. And then the last one is the ulnar. What does the ulnar nerve do? Feels here, does this. Does that make sense? Okay. So that gives you a place to start with your memorization, so that it's not all just rote memorization. It's got some logic to it. Everybody okay with that? Okay. Any questions? No? Okay. So now we move from the cervical plexus, from the brachial plexus to the notoplexus. And the notoplexus is the thoracic spinal nerves. And the thoracic spinal nerves, they stay parallel to one another. Oh, where the hell's the picture, Melanie? Okay. They stay parallel to one another, so they never actually form a plexus. So here they are. Okay. So they come directly off of the anterior rami, right? And then they mostly run between the ribs. So what muscles do you think that they innervate if they run between the ribs? Yeah, external and internal intercostal muscles is primarily what they innervate. Does that make sense? Okay. They don't form a plexus. Here's what they look like if you go all the way back up here. The thoracic spinal nerves, T1 through T12. They don't form a plexus. They innervate the intercostal muscles. Their sensory function is pretty much the same area. Their sensory function is sensation from the lateral to anterior thoracic cavity, and they also go a little bit into the pleural cavity. So pretty much where you would think that they would have sensory functionality. Is that okay? Go ahead. No, they don't do the obliques. We actually don't learn the nerve that does the obliques. Okay? It's just because it's a weird pattern that you can't see in anything. So you don't learn all of the innervations, and you don't actually want to, do you? So you're like, I can't wait for you to shut up already. And this is only about a quarter of the muscles that you learn. So, but we're putting some of them together at least. Okay. So now we are, oh, by the way, I always ask on the next test something that makes you try to say thoracic plexus. But it doesn't form a plexus, and I want you to tell me that. Okay. And it may seem like it's a tricky question, but it's not a trick if I tell you that I'm going to do it. Right? Okay? And some of you guys are still going to write thoracic plexus. I'm going to tell you there isn't one. Okay? So now we are going to move down, and the next plexus we are going to find is the lumbar plexus. So the lumbar plexus is about L1 through L4, sometimes some fibers from L5 in it. And please note that the lumbar plexus runs anterior to the os coxae mostly, and the sacral plexus runs posterior. Now, the lumbar plexus is far more complicated than we actually learn it, but what it does, big picture, is mostly innervating the thigh, both sensory and motor activity of the thigh. But you only have to learn 2 nerves out of it. But let me just show you sort of what the lumbar plexus looks like if you actually looked at it more carefully. So it's going to, you can kind of see what it's actually doing because it's got the ilioinguinal nerve, which kind of tells you where it's going, the genitofemoral, the lateral femoral cutaneous, and then the femoral and the obturator. So it's kind of thigh and junk area, but it actually doesn't do external genitalia. It does some internal stuff, okay? Now, It's pretty easy for you guys because you really only learn 2 nerves out of it, and they're really easy to identify one from the other. And they are simply these. If you see it running completely down the anterior portion of the thigh, it's the femoral nerve. It's got a whole hell of a lot of branches, but you don't have to know any of the branches. Anything that's running directly anterior on the thigh is the femoral nerve. Is that okay? And then the only other nerve that you have to know is the one that is medial to that and runs inside the thigh, and that's the obturator nerve. Why do you think it's called the obturator nerve? Because it goes through the obturator foramen. Exactly. Okay? Everybody okay with that? So now let's just learn a little bit of what each of those nerves do. And you don't have to know any of the rest of them, okay? You do need to be able to recognize that that's the lumbar plexus, but you don't have to identify nerves out of it except for those 2. Okay, so the lumbar plexus, and specifically the femoral nerve, does 8 of the anterior thigh muscles. And they're mostly anterior. They're definitely not posterior. Some of them are a little bit medial. And then the sensory function is really weird. I'll show you the picture of its sensory function. So when you look at the sensory function of the femoral nerve, it basically innervates everything that it goes by. So if you look at how the femoral nerve goes, it goes down the anterior thigh, and then it runs medial, look, all the way down to the inner surface of the foot, okay? And everywhere that it runs, it actually has sensation. Okay, does that make sense to you? So the sensory function of the femoral nerve is really all the way down onto the arch of the foot, all the way down. Does that make sense? So the whole anterior portion down to the arch of the foot, that's what it does. And then the muscles that it innervates are all of these guys right here. Okay, so what it's going to do is 8 anterior thigh muscles, all of the quadriceps, right? Because there's 4 of those. Rectus femoris, all of the vastuses. And then the iliacus and the psoas major, the sartorius and the pectineus. So, can we oversimplify a little what the femoral nerve does? So the femoral nerve feels what? Feels all of this, yeah, and does what? If you oversimplified it just a little bit. It would do flexion here and extension there, right? Because that's what all of those anterior thigh muscles do. Add in a little bit of these things, but just to get a big picture understanding, right? That's what it does. Everybody good? Okay. Didn't you already have this written in your lab? No, you haven't done it yet? Okay. Okay. So, obturator nerve, I want you to look at where it's going so you can sort of predict what it's going to do. So, where's the obturator nerve going? Yeah, through the obturator foramen into the medial thigh. So which muscles do you think it's going to innervate? The abductors primarily, and then some friends that are around the abductors. Does that make sense? Okay. So what it is actually going to do, the obturator nerve, oops, not that one, is going to innervate all of these adductors, the gracilis. Does that make sense? So it's going to innervate 5 medial thigh muscles, adductors, gracilis, and then it does a little bit of the pectineus. It helps with that. Is that okay? Kind of makes sense looking at where it goes. Okay. And then what does that one do sensory? Well, the sensory function is exactly where it goes. So the sensory function of that one is this. It's the medial thigh, the proximal medial thigh right here. Okay? So it innervates the adductors and it has proximal medial thigh. So what does it actually do? It actually does that, right? Feels here, does this. If somebody touches you here, there better be some consent involved, right? Or else there's going to be some adductor action and maybe also some other action, right? So, make sense? Okay? So feel here does this. That's what that one does. Cool? Okay, so sacral plexus is next. You guys are really quiet today. Are you getting this or no? You're just writing too much to listen? Is that what's happening? Okay. That's why I'm glad you guys have your notes every day, because you usually actually listen. But when you have stuff to write, you're like, I can't listen. But you already did it, didn't you? Okay. So the sacral plexus is next. Let me show you where the sacral plexus runs so that you can start to figure out what it does. Not that one. Okay. So the sacral plexus is going to run, it's going to start out on the sacrum, run anterior to the sacrum, but that's going to run posterior to the os coxae. Everybody okay with that? So if you were looking for the sacral plexus, would you look usually for those nerves from an anterior or a posterior cadaver? Yeah, usually posterior. So you're usually going to find them like this, okay? Although they came out the anterior portion, right, of the sacrum, they actually run posterior. They run down that side, okay? And it includes the biggest nerve in the body, which is the sciatic nerve, which doesn't actually innervate anything directly, but it immediately splits into a couple of branches, the common fibular and the tibial nerve, and those will innervate things, right? And then there's going to be a couple of other nerves that are involved in there. Now, with these, I will go ahead and tell you that you will not be able to figure out the nerves of the lower leg without practicing on the cadaver, and here's what you should do. Don't just look for the nerves and point to them. Figure out which one's supposed to go anterior to the lateral malleolus, which one's supposed to go posterior, which one actually ends up on the dorsal surface of the foot, so that you can know that you're getting them correct. You don't just identify them at one point, you have to follow them to figure out where they're supposed to go. Okay, so I'm going to show you on the picture, but you realize that the picture doesn't look a damn thing like the cadaver, so you're going to have to practice on the cadaver. Okay, so let's look at these. So the sacral plexus is going to give rise to a couple of nerves that are pretty easy. They're not necessarily easy to find on the cadaver, though, and they are the superior and inferior gluteal nerves. Do you see those guys? They kind of go out that way. Now, why are they hard to find on the cadaver? Well, because they get broken really easily by students. The way that you will find them, though, if we still have them on a good cadaver, is you will separate the gluteus maximus from the gluteus medius, and they're going to be running between them. Okay, kind of like the lateral and medial pectoral nerves, right? Okay, but if you're not gentle when you're doing that, you'll pop them. So be one of those students who is really gentle with the cadavers, and if somebody is not being gentle with the cadavers, be one of those students who's brave enough to tell them to chill. Because what happens when they break things is that you still get tested over them, but they're way the hell harder if you can't see where they're going, right? So they're really making it harder on everyone. Okay, so the lateral and, superior and inferior gluteal nerves, what do those do? Well, the superior gluteal nerve does 3 muscles that are in the gluteal regions, but not the ones you would expect it to do. Has no sensory function. So what that one does is the TFL, what's the TFL? Tensor fasciae latae, and the gluteus medius and minimus. And then guess what the inferior one does? Yeah, it does the maximus. That's what's left. Cool? Okay, and it doesn't have any sensory function either. So TFL, medius, and minimus, and then this one does maximus. Good? Okay. Now let's do the other ones. Okay, the sciatic nerve is enormous. So if you can't find that, you probably should not pass your lab practical, right? Because it's a big honker. It's huge. It's running down sort of the lateral and posterior surface, and you can find it in a bunch of different places. And what it really is it's actually a collection of a couple of other nerves that are about to split. It actually is going to split into the common fibular nerve and then the tibial nerve, and then the common fibular nerve will split again. So let's look at what each one of those is going to do. So the sciatic nerve is going to split into the tibial nerve, and let's watch where the tibial nerve goes. You ready? So here's the common fibular. It's going to go lateral, right? And then the tibial nerve is going to go posterior, and watch it go all the way down to the bottom of the heel, okay? And put that in your mind when you think about what it does, okay? So what is that one actually going to do? If you watch how it courses, you probably won't be surprised that it does the posterior thigh and the posterior leg muscles. And then what it innervates as far as sensory function is going to be related to where it goes after that. So the sensory function is the plantar surface of the foot and the heel, because that's where it went. Does that make sense? Okay. So it does posterior thigh muscles, biceps femoris, the long head. We'll pick up the short head in a second. The semimembranosus, the semitendinosus, a little bit of the adductor magnus, even though we innervated most of it with the obturator nerve. What's the FDL? Flexor digitorum longus. What's the FHL? Flexor hallucis longus, right? So the tibial nerve really does most of the back of the leg, thigh and leg, most of the back of the thigh and leg. Go ahead.
There's more.
Oh, sorry, I've got more on there. Yeah, that's right. Okay, and then the rest of the lower leg, gastroaxilleus and tibialis posterior. Does that make sense? So what's, if you had to say sort of what the parallel in the arm is to the tibial nerve and the leg, what would it be? Yeah, it's kind of similar to the radial nerve in its motor function, right? Because the radial nerve goes down the back of the arm and the forearm and innervates most of the muscles back there. And then the tibial nerve goes down the back of the thigh and the leg and it innervates most of the muscles there. But its sensory function is different because it really only does the bottom of the foot and the heel as far as sensation goes. Is that okay? Okay. So that's the tibial nerve. And then all we have left is a couple other nerves and we're almost done. Okay. So the common fibular, let's find it. Okay. So if we look at where the common fibular is, the common fibular is going to innervate something and then it's going to split into the superficial and deep fibular. So when the common fibular innervates something, it's going to be something in that region. So one posterior thigh muscle that we had left, which was the biceps femoris short head. Yes? Okay. And it has no sensory innervation. Does that make sense? Is it in the right location to do the biceps femoris short head? Yeah, it is. Yeah? It's got a little branch that goes there to the biceps femoris short head. Okay. Almost done. Okay, we're going to split into the deep and the superficial fibular, but I want you to see where they go so that you can reinforce this when you go back to the lab. So the common fibular is here, and the common fibular is going to, ooh, where is it on that picture? Split, maybe it's in this one. Okay. Nope, that's not it. Okay. All right, so the common fibular, this is an anterior view. So it's common fibular, it's running down in the popliteal region, right? And then it's going to split, and it's going to go superficial fibular, but I want you to watch where the superficial fibular goes. Watch. It's running superficial, it's running lateral, and then where is it going to end up? It's going to end up on the dorsal surface of the foot. Do you see that? Okay, and then watch the deep fibular. The deep fibular is going to go deeper and more medial, right? Does that make sense? And it's going to end up staying deep. It's not going to end up on the superficial surface of the foot as much as this one does. So let's look at where these actually innervate. Okay, so the deep fibular nerve is going to innervate 3 anterior leg muscles, and then what it's going to do is a weird sensory function. So the 3 anterior leg muscles are the tibialis anterior. That's okay, right? Okay. The EHL, what's that? Extensor hallucis longus. The EDL, extensor digitorum longus, good. And then the sensory innervation is so damn weird for this muscle. The only place that it actually has sensory innervation is between those first 2 toes. So here's its sensory innervation. That's the flip-flop irritator right there, right? So, you know, bad flip-flops, the kind that you buy in emergency on vacation because you didn't remember your damn flip-flops that eat your toes to death. It is because they are irritating the what nerve? The deep fibular nerve. Yeah, okay? That's a really weird innervation. And then the superficial fibular. The superficial fibular does 2 of the lateral leg muscles, these guys right out here, okay? And the rest of the top of the foot, because that's where it ended up. So let's look at it real quick and then I'll show you again. So this one is actually going to go, okay, so here we go. Nope, not that one. We are going to end up right here and on the surface of the foot. You see that? Okay, and what that one is going to do is it's going to innervate the fibularis longus and the fibularis brevis, and then the sensory function is going to be the last portion of the leg and the top of the foot. Longus and brevis. Okay, so where's that picture too? So I'll show you what that one innervates by looking at this picture. So what does that one actually have sensory innervation? The top of the foot. And notice that you left out the 2 little toes right there. That's funny innervation. I wonder how that evolved. Okay, and then the last nerve that we are learning out of here is the one that they keep trying to convince me to delete, but I just will not do it. And they want me to delete it because it is really hard to find on the cadavers, but it's super duper important. And that's this little guy right here called the Pudendal Nerve. And the Pudendal Nerve was found first because it actually innervates the female genitalia. And the word pudendal or pudendum means shameful. So this is the shameful nerve. And then later on, they figured out that it actually innervated the penis too. And I'll bet they wanted to change it to the super duper coolest nerve ever. So what does the Pudendal Nerve do, and why do I make you learn it, even though it's super duper hard to find in the cadavers? Well, because it's the reason you're here. Because this muscle, in addition to helping your sphincters hold on to things, this muscle actually innervates the external genitalia, including the penis and the clitoris. And you literally would not be here if it didn't exist, right? None of us would. Okay, and then the other things that it does, it innervates the muscles of the perineum, all of those muscles that keep your junk in, and then it also innervates your external sphincters, which are also really important, we can agree, right? So that's the Pudendal Nerve. So it has motor innervation, and it also has sensory innervation to the external genitalia, the clitoris and the penis. And the penis and the clitoris are the same embryological anatomical structure. They are identical. Every single one of us has a penis, just varies in sizes. Okay. Some of our penises have a urethra within them, and some of them do not, right? Just ends up. So at the end of the semester, I'll teach you how you got to be a sex at all, how like the development of the sexes actually occurs. In the last class, somebody actually asked what the clitoris was for. That's a Utah education for you right there. I was like, oh, pumpkin. I think I even said it, pumpkin. So we will learn that at the end of the semester. Okay, everybody all right? Yes? You know they're not allowed to teach it in Utah. It's not actually involved in procreation. So you don't get to talk about it. You don't get to talk about anything related to pleasure in Utah public education, which is why my kid, now that he's in 8th grade, even though he doesn't want to, he has to go to the real sex ed class at the Unitarian Universalist Church where they actually teach him all the stuff and bring Planned Parenthood in there. And they don't let the parents come because they will not ask questions if you are there. So he's like, do I have to do this? I'm like, yes, you absolutely have to do this. I do not want to be a grandmother. Okay, so everybody okay? I mean, I do eventually, but not tomorrow. Did you teach your boys? Yes?
Yeah.
Okay, good. Because you got a 15-year-old, right?
They started school in Colorado.
Oh, okay.
They got it.
That's good.
Early.
Yeah.
5th grade.
I tried to get on the board to do the updating of the Utah science education standards and sex education standards. They didn't want me. What? They did not put me on there. I cannot believe it. I'm like, I seriously know this stuff. And they're like, that's the problem. Okay. So the last part of the nervous system stuff is just to get you guys an understanding of the autonomic nervous system, not because you do it in lab, but because you need it for physiology. Okay. So you do not look at most of these structures in lab, not because they're not important, but because in order to see these autonomic nervous system structures, you usually have to kind of destroy the rest of the cadaver in order to see it. So we can't usually take, for instance, all of the organs out of the ventral body cavity just so you can see the autonomic structures. So they are important. You don't study them in lab. Also, lab is a little busy. You know, there's a lot already in there. Do you want me to put 100 more terms in there? No, you don't. You're like, screw you, Melanie. There's too many terms anyway. But you are going to be so smart when you leave here. Okay, so when we're talking about the autonomic nervous system, we have done this terminology before, but it's been a little while. So let me just ask you a couple questions to make sure that we're all on the same page. So it's also called the visceral motor division. Yes? Here's my question for you. If I say autonomic nervous system, am I talking about CNS or PNS? PNS, yes? Good. Okay. Am I talking about afferent or efferent? Efferent, yes? Am I talking about voluntary or involuntary? It's involuntary. Yes, it's involuntary. So why is it involuntary? Let's go back to what we learned about the brain. The only way that anything can be voluntary is if it's mapped to the cerebral cortex, correct? This is mapped to structures that are far older than the cerebral cortex. It's mapped to the hypothalamus, to the medulla oblongata, and to the pons. So at least theoretically, evolutionarily, these functionalities are older than what we consider consciousness. Yes? So the tissues that they control, also called the effectors for the autonomic nervous system, are cardiac muscle, smooth muscle, and glands. So why are we studying this? Well, you guys are going into human health, I would imagine. Otherwise, you wouldn't be taking this class, right? Cardiac muscle, smooth muscle, and glands ends up controlling a whole bunch of your vital physiological processes. Cardiovascular, urinary, respiratory, digestive, urogenital, all of that has cardiac muscle, smooth muscle, and glands, one combination or another in there. So you need to kind of understand how it's wired up at least. Okay, so it is generally involuntary and automatic, although in certain circumstances, the cerebral cortex can override what the autonomic nervous system is doing. So I know you guys have heard of this before. It's kind of fun to talk about. I totally want to do this phys lab, but they won't let me. So a polygraph test. What a polygraph test is, and we'll talk about whether it's sciencey or not, whether there's actually empirical evidence for it, and what actually you can find out from a polygraph test. So you guys know, of course, that your autonomic nervous system is divided into the sympathetic, which is fight or flight and exercise, and parasympathetic, which is feed or breathe, right? So most of us who are not sociopaths will, when we lie, we get a spike of fight or flight because we're afraid of social repercussions of lying, right? We've sort of been conditioned to be afraid of social repercussions. And we may not even notice that fight or flight response a little bit. So what you can do is you can look for physiological evidence that the sympathetic nervous system has been activated. You with me so far? And that physiological evidence can be several different things. It can be pupil dilation. It can be heart rate going up. Right? It can be bronchial dilation, which will lead to an increased respiratory rate, even though the diaphragm is somatic, still bronchial dilation. And then it usually heats up your body, so you usually have an increase in conductivity of the skin. Does that make sense? As you start to sweat just a tiny little bit. And even though it's somatic, usually occurring at the same time as your anal sphincter usually tightens up. Totally does. Now when they do polygraph tests, you can even sit on a little sensor that can tell if your anal sphincter is tightening up. So why is it that some like CIA operatives, at least in the novels, and some yogis, right, can have fight or flight responses that they can control ultimately, so that you can have an undetectable response on a polygraph test when you are the born identity or whatever the hell. Does it really happen? And the answer is yes, with an asterisk. Some people can train themselves into doing that. So what's going on when that occurs? What's going on when that occurs is if you wire me up, and I actually did kill somebody, I didn't. If you wire me up and you ask me questions about what I had for breakfast and my mother's maiden name and a bunch of crap, then you can get my baseline level of stress, which is I'm in a police station and you're questioning me level of stress. But then if you ask me if I saw her on the night of the murder and I lie, you can see a spike. And then if you get ask me if I chopped her up and put her in the trunk and you see a spike when I lie, or if I'd ever met her, all of that. And then basically you can get a pattern that shows that you were not being truthful about certain types of questions. But of course in this country, are polygraph tests admissible in court? They are not. They're not admissible in court. And that's in part because they are so subject to human error. The polygraph examiner can be fantastic and their results can be really, really reliable, and they can be not very good and their results will not be very reliable. So that information can't be entered into court. Do they still use it? Yeah, they still do use it. But even if you failed a polygraph test, all it will do is keep you as a suspect when you already were, because you were asked to do a polygraph test. I totally want to do polygraph tests in physiology. Don't you think that would be fun? Because they have terrible ideas and I have fun ones. Because I'm not the curriculum director for Phys Lab. I'm the curriculum director for Anatomy Lab. That's why it kicks ass. Okay, but they won't let me. I thought it would be a great way to measure I mean, even though, so is it sciencey or is it science? It's just sciencey. It's got some relationship to science, but it's not really reliably repeatable. It's relatively variable from person to person. So what happens with the CIA agent or the yogi is they practice hooking themselves up to a polygraph test, seeing the spike, trying to quell the spike with their cerebral cortex, telling their medulla oblongata to shut the hell up, telling their hypothalamus that everything is fine. And so with repetitive activation of that biofeedback, you can quell the detectable responses in the sympathetic nervous system. I don't know if you can still do it with your anal sphincter. But don't think I wouldn't get one of those pads and then wire you up in phys lab. And you would love it, wouldn't you? I think it would be great. I mean, you might not volunteer to be the one, but there always is one. You know there's an extrovert in every class who's going to volunteer, right? Every single class. Okay, so cerebral cortex can sometimes override. Probably not in me and probably not in you. Can you lower your heart rate to the point that it wouldn't be detectable? Okay, so there are two divisions. We already know this. They are sympathetic and parasympathetic. Which one is fight or flight in exercise? Sympathetic. And which one is feed or breed? Parasympathetic. Okay, so here's something that's kind of hard to explain, so let me just try to explain it to you. The effector organs, meaning cardiac muscle, smooth muscle, and glands, for the autonomic nervous system generally have what we call dual innervation. And dual innervation means picture the heart, and I want you to know that it's got two sets of nervous system hookups, yes? Okay, and I want you to think of them kind of as gas and brakes, okay? So one of the ways that we could actually increase the heart rate is to take our foot off the brake, and then the speed would go up. But what if that was inadequate? Then we could actively stimulate it with the gas, yes? Okay, one of the ways that we could slow it down, take our foot off the gas, yes, and it would slow down, but what if that was inadequate? We could put our foot on the brakes. Does that make sense? Okay, so we could put our foot on the brakes. So what you have with autonomic effector organs is two hookups. That's not what we have with skeletal muscle. Skeletal muscle just has one hookup and either you stimulate it or you leave it alone, okay? So with autonomic effector organs, we have two sets of hookups for every autonomic effector organ. But the gas is not always the gas and the brake is not always the brake. So let's talk about that. So what people like to think that isn't true and shouldn't be true is that the sympathetic nervous system, the fight or flight division, increases the activity of all of its effector organs, and that the parasympathetic decreases the activity of all of its effector organs. But that would be really problematic when a tiger walked into the room. So I want you to think about what should happen. What should happen is, let's choose any two effector organs. We will choose the heart. Everybody can picture. And then we will choose the smooth muscle of the digestive tract. Yes? Okay. So right now, you're not particularly stressed out. You don't have a quiz. Your midterms are over. Everything's cool, right? So what's going on right now is primarily parasympathetic activity. Feed or breed, everything's cool. So the parasympathetic activity is probably telling the heart to do what? Slow down, right? Parasympathetic says chill. But what does the parasympathetic say to the smooth muscle of the digestive tract? It's a good time to work, right? We can afford to do that right now. So that's what the parasympathetic has going on in you right now. Okay, tiger walks into the room. Okay, tiger walks into the room. What I need to do is I need to take my foot off of the parasympathetic nervous system and put on my foot on the sympathetic nervous system. But let's think about what the sympathetic nervous system is going to do. What the sympathetic nervous system is going to do to the heart is what? Increase it. What's the sympathetic nervous system going to do to the smooth muscle of the digestive tract? Decrease it. Yes? Okay. So how did you figure that out? Well, you just logicked your way through it, right? Because you know if you have finite resources, you need to be careful about how you spend them in fight or flight situations. So the sympathetic increases the activity of any organ that could potentially help and decreases the activity of any organ that couldn't potentially help, right? So with that in mind, can you imagine what the sympathetic nervous system would do to salivary gland secretion? Shuts it off. Can't afford that right now. What should the sympathetic nervous system do to the pupils of the eye? Dilate or constrict? Dilate, because I need more light in, right? So you can figure it out if you just think about resource allocation, right? And almost all the time it'll work. There are a couple of weird little exceptions. Does that make sense to you guys? Okay, so now what we have to do is look a little bit at the anatomy of the autonomic nervous system. So I want to talk about the pathway that you would use to start fight or flight or feed or breed. Okay, so this looks super complicated, but it's totally not. So what we are going to do is we're going to look at two pictures. They're both pretty much going to end up at the same target organs, right? Here's picture number 1. Here's picture number 2. Notice that they end up at the same place, okay? Picture number 1 is the parasympathetic nervous system and its effector organs, okay? It's easy to tell the parasympathetic nervous system because it innervates all of its effector organs from 4 cranial nerves and then not a damn thing until you get down to the sacral region of the spinal cord. Is that okay? Okay. What are those 4 cranial nerves? Can you remember them by number? What is 3? Oculomotor. Remember when you were looking at the list that it had somatic and autonomic function? That's what we're talking about here. Okay. Now, what is cranial nerve number 7? Facial. What's cranial nerve number 9? Glossopharyngeal. And cranial nerve number 10? Vagus. Vagus is a workhorse. Look how much parasympathetic innervation it does. Almost the whole ventral body cavity until you get down to the bottom part of it and the pelvic, right? And the external genitalia. So what is this going to do? That's going to do just the stuff that's in the pelvic cavity and the external genitalia. Everything else in the ventral body cavity is primarily coming from the vagus nerve for parasympathetic innervation. Okay, and then for sympathetic innervation, you end up at the same place, but you have a different anatomical route to get there. Okay, so here you go. Same place, but notice no cranial nerves involved, nothing in the sacral region. Yes, it's all from the thoracic and a little bit of the lumbar region. Does that make sense? So the way that you actually get out to the same target organs is like this, okay? All from the thoracic and lumbar region. Everybody okay with that? So let's put that into practice of what we talked about just now. So you're chilled out right now, and your parasympathetic nervous system is telling your heart that it can chill and your guts that they should contract. Yes? Okay. So now I want to talk about how that message is getting to those locations, right? So what's happening right now is this complex interaction with your cerebral cortex noticing that you're relatively safe. Yes? Okay. And that is actually interpreted and sent to your medulla oblongata, which will tell, for instance, your heart that it can chill, right? So how am I going to send that signal out to chill to the heart? It's going to come out of cranial nerve number 10. Okay, cranial nerve number 10, I've got a pair of them. They are going to go down and they are going to tell my heart to chill out. And then it's going to have another branch that goes down and tells my guts to contract. That's what's going on with you right now. Cranial nerve number 10 is controlling what's going on with your ventral body cavity. But then a tiger walks into the room, okay? I turn off that stimulation that was going on right there, and instead I do this pattern in which my cerebral cortex says, oh shit, tiger, okay? It goes down and it sends that signal to the medulla oblongata that says, hey, we need the heart rate to increase. And the medulla oblongata sends the signal down to the thoracic region of my spinal cord, which sends it out to my heart, increases my heart, sends it out to my guts, decreases my guts. Right? That's the anatomical route that you use to get to those places. Is that okay? Okay? All right. So, the only other thing that I'm going to tell you guys today, and then I'll let you go for today, is that with the autonomic nervous system, it has a little bit of a weird pattern. So when you're trying to get from the central nervous system all the way out to the effector, notice something with me for just a second. Notice that there is a brown neuron and then there is a blue neuron. Do you see that? Okay. Because in the autonomic nervous system, the way that you get out to the effector is 2 neurons in series with a ganglion in the middle. Okay. Brown neuron, blue neuron, ganglion in the middle. But this is a motor ganglion. So is this going to be in the posterior root? No. You haven't met this ganglion before. So the posterior root ganglion is sensory. It's not involved in this story. This whole story is motor, right? So these ganglia you actually haven't met before. So last little tidbit is where the ganglia are located in your body. So where are these ganglia on the way? The place the ganglion is located depends on whether you're sympathetic or parasympathetic. Remember the brown one, we're going to call that the preganglionic neuron. And then the blue one's the postganglionic. So I want you to look at the parasympathetic nervous system and notice that the brown one is really long and the blue one is really short. Do you see that? That means that with the parasympathetic nervous system, the ganglia is two choices: closer to the nervous system or closer to the effector. Closer to the effector, sometimes even on the effector. This time it's just as close, right? But this time it's actually on the effector, okay? That's the parasympathetic nervous system. The sympathetic is different, and then we'll stop for today. Ready? Okay, the sympathetic nervous system has short brown ones, long blue ones. That means that the ganglia are, again, close to the nervous system or close to the effector. Close to the nervous system. As a matter of fact, they are in a chain or in a line on either side of the thoracic region of the spinal cord because that's where they're coming from. Yes? And these are all sympathetic. They're all involved in your fight or flight system. And you can see them on the cadavers if you're willing to take everything out of the thoracic cavity, because here's where you would find them. These are called the sympathetic trunk ganglia or the sympathetic chain ganglia. And this is an anterior dissection. If I did an anterior dissection and took out the heart and took out the lungs, what I would see is a bunch of chunks right between the ribs on either side, right? But can you see why, in order to do this dissection, we kind of have to sacrifice the entire cadaver, so we don't choose it to do it very often? There usually is at least one cadaver on each campus in which if you pull it aside, you can actually see the sympathetic chain ganglia. Is that okay? Okay, and we will stop there for today, and we'll get into the last part of it next time. So you all did your quiz. I'll put up another quiz, but it probably won't be until like Sunday or something because everybody's going to do Halloween and all of that stuff. But I will put up a quiz. And by the way, I'll put up a quiz that makes you really think about innervation. Like instead of just asking you which muscle it innervates, I might ask you which one is in control of flexion of the leg at the knee, right? Or extension of the wrist. Is that okay? So that you have to put together all of this stuff that you've been doing in one story. But as long as you can have some time to work on it, you can do it. Okay?